Here is the NMR spectrum of ethylbenzene, and ethylbenzene has got 5 different types of protons in it. Let's identify the different types of proton. Okay, first, when you look into the ethyl group has itself 2 different types of protons. One from the methyl group itself, one type of proton from the methyl group itself, and the other type of proton from the methylene carbon that is attached to the methylene carbon. And then these 2 hydrogens which are in the ortho position are going to be equivalent, and again these 2 hydrogens in the meta position are going to be equivalent as well, and you have one hydrogen which is existing in the para position. Okay, let's go on to the splitting pattern. The methyl group has 2 neighboring protons, and therefore it's going to be split as 2 plus 1, which is going to be a triplet, right? And you can see this triplet right here. Okay, and similarly, if you look into the methylene group, the methylene carbon has 2 hydrogens, and the number of neighboring protons right here is 3. So it is going to be split as 3 plus 1, which is going to be a quartet, right? And that quartet is right here, which is going to be equivalent to the intensity of 2 protons, right? And all of these three different types of protons, they all exist as a multiplet, which you can see somewhere between 7 and 7.3. Okay, and that's because the electronic effect of the ethyl substituent is similar to that of the hydrogen, and that's the reason they are going to split as a multiplet. Here is the HNMR spectrum of nitrobenzene, and when you compare it against the HNMR spectrum of ethylbenzene, you can see that the aromatic protons are actually going to exhibit distinct signals for each of the different types of protons present. And that is because of the strongly electron withdrawing effect of the nitro group. Okay, and you can see that these are the ortho hydrogens, okay, and these are the meta hydrogens, and this is the para hydrogen. And you can see there are 3 different types of protons, and you can see there are 3 different signals that exist for these 3 different types of protons. Okay. The ortho hydrogens, which are very close to the nitro group, are said to be de-shielded. Okay, and that's because again for the strong electron withdrawing effect of the nitro group, and they exist as a doublet because there is only one hydrogen that's present in the neighboring carbon, right? And when you come to the para hydrogen is going to be the next de-shielded proton, and that's going to exhibit a triplet. You have 2 hydrogens here, and therefore it's going to be existing as a triplet, right? So 2 plus 1, that will be a triplet. And when you come to the A protons are actually going to be existing as doublet of doublet, okay, because of these 2